So I'd like to introduce you to the zCAT. The zCAT is the world's first truly portable DCC coordinate measure machine. By portable, I mean it weighs 30 pounds. It's battery operated. It can run on AC or on battery. Right now we're running on battery. The zCAT will run about 4 hours on a full battery charge. I can put it on a table, as you see it here. I can put it on a surface plate. I can put it on my desk. I can put it on the bed of a machine tool. I could put it on an airplane and carry it off to visit my customer and bring my CMM with me. So you can see the zCAT is DCC, direct computer controlled. It's now running a few different individual dimensions strung together in a program that I did earlier today. It took me about 5 minutes to write this program. So the gauge being portable, not only is it portable, but it has its own Wi-Fi network. You can see an antenna here. So right now it's communicating with the PC. It's sending data. Every dimension, it's sending the data into the PC, in this case just a simple Excel spreadsheet. The zCAT has 4 axes of measuring. We have a rotary encoder in the base, so that the gauge can rotate 360 degrees. Therefore, we can stage parts 360 degrees around the zCAT. I have 3 small parts here right now. I have a rotary encoder in the probe, so that can rotate 360 degrees, and you'll see the 2 stylus we have on here. So it's toggling between the two, the horizontal and the vertical, using whichever one is the best for the particular dimension we're measuring. The zCAT has 2 linear scales, one in the z-axis. It has about a 250 millimeter z-axis. We have a linear scale in the cross-axis. So at any one time you'll see 4 readouts on our screen here, showing the X, Y, Z, and P being the probe. Now, it does have 4 axes of measuring, but it's actually measuring in 3 dimensions. So it is measuring in X, Y, Z in the final results. In this case, it's sending those results into an Excel spreadsheet. So on the zCAT, we have a touch screen. This is the same touch screen that you'll find on an iPhone 5. And that's where we're going to control it using this internal software. The zCAT has its own built-in software called ControlCAT. It's all icon driven, so we can teach any operator how to use this if they understand simple icons like a diameter, an angle, a line, a point, a sphere, a cone, a cylinder, all the simple geometry symbols that you might see on any coordinate measure machine or any drawing. So we can teach the same operator who's making the part how to measure the part. So they can learn how to program it internally with ControlCAT. And that's what I've done here. So it's just measuring a few dimensions on a few different parts. So, and toggling between the two stylus. We also have the option of adding a wire connection using an Ethernet cable if the Wi-Fi is not conducive for the atmosphere. Some companies don't want Wi-Fi, therefore we can hardwire it to the PC to send the data out. We also can archive hundreds and thousands of programs on a PC. We can store hundreds of programs on the zCAT itself to be recalled tomorrow, next week, next month, whenever. So I'm going to go ahead and stop the zCAT by just touching the touchscreen. It will cause, there's an e-stop operator, you want to continue, yes or no, and I'll hit no. So now I'll take control of the zCAT by grabbing the handle. So now you can see this is how the operator would program the zCAT and use the zCAT. This black ring allows them to grab the arm, and you can move it up and down, in and out, left and right. And again, you can see how we can move it around to reach the part. So it's very simple to program. Again, like I said, we've got icons on here. So something simple as a diameter, I can go to the screen and I can touch the diameter. I can then hit the enter button, and it brings up another window saying, okay, we need to take a minimum of 3 points. So I'm going to measure this large diameter. So I'm going to give it a go-to right there. By a little twist will allow it to drive to a certain position, and I'm physically going to come in and touch 4 points. I could do 4, I could do 24. Any combination from 3 or above. But 4 is enough for demonstration purposes, and I'm going to give it one more go-to. I have another option of go-to on my screen. So when I finish, I'll hit the enter or the check mark again. The diameter is flashing. I can then bring it onto my screen. I can highlight it and I can hit go. So now it's going to go to the same locations. It went to the go to, it's measuring the points, but now it's doing it under controlled speed. This is key because I could never go into those locations at the same speed, at the same angle every time. That's where the accuracy comes to the zCAT, because it does it under controlled speed. So every operator is going to get the same results. At the end of it, I have my diameter flashing. I can bring the results up on my screen. I have them here. If I want to archive them, I can just send it out into my Excel spreadsheet. And there it goes. That's circle number 4 and the results. So that is the same way I would program a line, an angle, a sphere, a cone, a cylinder, or any of the other dimensions we do with a zCAT, by manually telling it where it is and then running it under DCC. From there, we can stage different parts around and do different programs, but we also can go to the next level, which is our full 3D software package, where we can create drawings and do reverse engineering and all the different things that people want to do with CMMs today for a very minimal price. We can go to our MK4 software, and I'll show you that next. What I've done is I've loaded the MK4 software, which will now give us full 3D capabilities on the screen and communicating with the zCAT. The MK4 software will send commands to the zCAT telling it where to go, but I'm still going to program it like I do any other time manually. So when I bring up a screen, I actually have 4 windows. One is the YZ, one is the XY, and one is the XZ image. And then we have the XYZ, or the digital readout, on here. So right now we're in metric, obviously, and as I move the zCAT around, you'll see the display change based on where the probe is. So I'm using the vertical probe, so it'll tell us on the top we're using vertical probe number 1. So if I want to do a simple measurement, I just accidentally took a point, so I'm going to delete that point and start over on that. So I'll physically come down and touch. You'll hear an audio signal signifying you've taken a point. I'm actually hearing 2 audio signals. I hear one from the zCAT and one from the software. After I've taken the 4th point, it identifies it as probably a plane. And I'll confirm that it's a plane. I'm going to also do this as an alignment, so I'm going to align it and confirm it by the check mark. So you can see on the screen, it's created an image of that plane. Especially it shows in the XY location. So this is looking down at the part X and Y axis. So now I'm going to come down and I'll measure a line on my part. So in essence, I'm doing an alignment here. As soon as I take my 3rd point, it identifies it as a line, and I will say yes. I'll confirm it with a alignment and the check mark. And you'll see it creates that line on the screen. Now I'm going to come over here and measure one more line. And again, 3rd point, it says that must be a line. I'm going to confirm it. I'm not going to do an alignment here, because what I'm going to do is I'm going to actually create a point on that alignment. So I'm going to, on this part, I'm going to grab the point, and I'm going to hit this little wrench with my mouse, and it comes on and says, okay, that means I'm going to construct it. I'll click on one line, click on the next line, and it creates a point where those 2 lines intersect. I'll make that the alignment and hit the check mark. So now you can see on the screen, we've got a plane, we've got a line, and we've got a point. That point is my 0 point, so you'll see the 2 arrows here. So now I can actually run that under DCC. So if I go to my inspection tab and hit my run key, the computer is now telling the zCAT to go down and do those under computer control. So it's going to be doing it much more accurately than I could manually, because it's got a pre-programmed go-to speed, it's got a pre-programmed measurement speed, just like we have in our ControlCAT software. But it's going to vector perfectly, and it's going to go at an exact speed every time that I could never do manually. This is where a lot of the accuracy of the zCAT comes in. This takes it away from the machine operator and puts it into the DCC power. So we've drawn some dimensions on our part, and that's basically the alignment, but now I can actually go in and start taking measurements. You'll notice I take the fourth point, it automatically brings up a diameter. It is identifying that this is probably a diameter. So if we're doing planes, if we're doing lines, if we're doing diameters, it automatically will identify those without having to tell it that's what I'm going to do. So in this case, I'm going to say, yep, that's a diameter, click it. I can now actually grab the measurement with my mouse and put it out here and give us that diameter right on our screen. But I can continue taking other measurements. So I'll do a few more. Only now I won't even confirm it. I'll just take another diameter. You'll get an audio signal that says, wait a second, that might not be a good point, but in fact it is. So I'm going to continue, and it will say, okay, that must have been good, and there's my next diameter. Now maybe I want to measure a line now. Again, it'll give me that symbol, but as soon as that signal, and let's just say that's the end of my program for now. I can hit the check mark, and as you can see, it's drawing everything on my screen. So I can start grabbing dimensions and bring them out here. Maybe I want to know the distance from this hole to this hole in a horizontal, and maybe I want to know this angle here. Maybe this angle right here. I can just click on each one and bring it out. But now maybe I want to bring a new part and set it in the same location and run it again. I could do the same thing, set it in the right location, hit my play button. And not only is it going to, well, first it asked me, do I want to use the same reference? And I say yes, because I haven't really, it's in the same location. Again, it will measure every dimension that I did before, and it will update the screen. So if a new part comes in and something has changed, it will be updating the screen too. So anything that changes will be updated automatically. So the operator can put the part down, hit the start button, go pick up part number 2, get ready, get prepared while it's measuring this one, and it will do this, draw it on the screen. You can easily print out many different reports. One that looks like a blueprint of the part, one you can do statistical analysis, you can do all kinds of reporting, you can download it into an Excel spreadsheet, but we have everything. So now it's going to do the diameters that I did, and it will update them on the screen. You'll notice on the screen where it's green is the next dimension it's going to do, and you'll see the probe moving around. The little red dot is telling you where the probe is at all times. And again, we could do this entire part using the MK4 software and the zCAT to actually do a drawing of your part and create it. So this can be as sophisticated or as simple as you'd like to make it. And again, we can teach any operator how to do this in a matter of minutes. They can be writing programs within an hour, probably less. It's very simple to use, very easy to operate, very user-friendly. And it's all completely portable and available to be measuring parts on the shop floor, right by the machine that's making the parts. And the same person that's making the parts could easily be measuring the parts. That's the zCAT.
Question.